my name is Gorazd. Yes, I'm 30 years in the compressor business, and today I will talk about my first 20 years designing the control systems and the last 10 years when I'm actually repairing those control systems that I install or design or build in the first 20 years. How is this possible? With monitoring. So I have two things for today which are important. So no control system without monitoring. Without monitoring, you cannot optimize the system, and the system is designed only for this one short moment. So if you want to optimize it, you have to monitor it. And the next one is the zone control, which is our new feature, new control approach, which includes also demand side. It's like in the heating system, you have a boiler room, which you control, but you not control only the boiler room, you control also the temperature in each room. And this is so-called zone controls also in the compressor room. So I work for CALMS, which is which is the independent compressed air platform, connecting different independent experts worldwide. Our system approach is based on holistic approach, action-driven, independent, and we have more than 1,000 systems worldwide as a database to learn and to optimize different kinds of systems. So what is the compressed air system? Compressed air system, as we see it from compressor manufacturer eyes, it's a big compressor room with a tiny distribution side, and also on a PID, normally we just mention the demand side. But in reality, the compressed air system, as seen by compressor auditor, it's a huge demand side full of different compressed air users connected with pipes, distribution part, and very tiny compressor room in one part of the building, and maybe another small compressor room in the other side of the building. So we would like to identify the savings. Where are the savings? Actually, this also depends from the eyes. If we see this from my eyes, when I was selling compressors, and my cost for energy audit was one new compressor or one new dryer or whatever equipment. So I was looking only in the supply side for the savings, and still 80% of all the auditors are looking the savings in the supply side. But actually, the biggest savings are on the demand side. We distribute this like this: 10% savings can be achieved on the supply side, 5% distribution side, and 20+% on the demand side. But demand side is a large area, as you saw, and it's time intensive for assessments, for evaluation, and there is no capital investment involved with the demand side. So nobody has interest walking around, identifying the significant end uses, repairing them, controlling them, and so on. So let's go further. How to approach the control and the management of compressed air system. Our approach is in 3 steps. First, reduce the compressed air demand. So you have to do an audit following with the repair for leaks and artificial demand. Then you go to the next step, find alternative sources, because compressed air is very expensive, 7 times more than electricity. So you try to identify inappropriate uses or tools, pneumatical tools that you can replace with an electrical one. And when you have done this, you can come to optimization and the efficiency of use, where is also the controls. To do this, we built in CALMS a 5-step approach, starting with the system assessment, which is system review, the first part. Then we find the potential savings, start with an audit, which should include supply, distribution, and the demand side. Part of the audit is also waste audit. leaks, artificial demand, and inappropriate uses. And then we have to train employee and do the employee engagement so that they all understand that we speak all the same language, so that we understand what we want to achieve, set the targets, set the responsible person, and then we can build permanent monitoring, which actually is the base where we can start optimizing the system. And this is also where controls comes. And at the end, we need to identify all those savings. We have to start with the asset management and total cost of ownership as well. There are many tools you can use in those processes, from graphs, histogram, correlation, 3D correlations, simulations, very important part, auto analyzers, events before, after, reporting, and permanent monitoring, and auto analyzers, and so on and so on. So those are the tools built in the platform, which you need to audit. And then we come to the control system, and there are some considerations that you have to be aware. If the system is not well designed, you have too big compressors, too small compressors, too many, not enough compressors. With the control system, you will not solve these problems. And the expected savings can be from 2 up to 10%. So that's what you can expect with the control system in the compressor room. You have to decide, consider the risk, reliability versus efficiency, and you always have to start with the audit. Then you do the simulation and write the correct functional specification for the system. In 80% of cases, you can solve this with a simple compressor bought by OEM, but in some cases where a more complicated, bigger system, you need to then go through all those considerations and try to fix the mistakes and finish the installation with the instrumentation qualification, operational qualification, commissioning, create a maintenance plan, monitor and optimize the system. So there are different modes for controlling the compressors as a master controller, but they all have the same goal: reduce the pressure, because the pressure reduction is connected to the savings. You have here 4 different types. For example, cascade control, which can be done with the manual or sequencer. You have a pressure band control, target pressure control, and then the one that I want to show you, it's a zone control, which is actually required target pressure for different zones, and then together with the master controller controlling the compressors to cover all this. So we are not controlling only the supply side, compressor room, but also the demand side, where are the biggest savings. You have to remember, and then you can come with the curve down. This is an example of control logic for a little bigger system with 2 compressor rooms. You have master controller controlling all the compressors with the logics that was described by Tim. Always controlling based on set point, pressure set point in the wet side in both compressor rooms. And then you have different zones controlled by flow controllers, and they report to the same master controller, sending the variable dynamic set point. So the set points in the compressor room are not fixed. They are based on different zone settings. So you can close one, you can shut down one zone, you can have a lower pressure in one zone. And with the flow controllers, the ability to control the complete system is much broader, and the savings can be achieved in overall with reducing the artificial demand. So this is one example of how this zone control works, and all the zones are then evaluated with the baseline. If there is some increase in the baseline, you can connect this with the leaks or demand profile improvement, so you can focus on the zone that has a problem. Here are just one charts. What I want to say is that even with the zone control and target, you have to be careful, because the control system, the master controller, must be aligned with the flow controllers with each zone. So, for example, here operation is very good, they are aligned, and here we simulated that the pressure at the demand side in the zone is stable, completely stable, but in the compressor room it starts to increase, and this causes also increase in specific and energy consumption as well. So it's very important to avoid these problems. And at the end, you have to consider the monitoring before-after situation with the events. So you have to evaluate the savings based on the targets. Here is one example. We are doing this based on IPMVP, International Performance Measurement Verification Protocols. So we set the baseline, then we adjust the baseline and compare the baseline with the reporting period and see daily savings and QSUM on average savings. Thank you. So that would be everything from my side.
This next question is for Gorazd. This one came from Matthew. If I am networking controllers, where should I be controlling the set point from? After the dryers or at the compressor? What is your ideal way to network compressors together?
So for a distributed system with multiple compressor rooms, we always use the controlling the compressor with the set point in the near the compressors on the receiver in the wet side. The end pressure is controlled by the flow controllers for different zones, and they are connecting together with the same PLC, which is controlling the demand side and the compressor rooms dynamically. So set point is changing. Set point is not fixed in the compressor rooms, but it's changing. But it should always look at the wet side in the compressor room.
So that's a very, I was going to add, that's a very modern and really new technology that he's recommending, and I think it's great. There's also systems where there's a simple controller in place, and sometimes the different pressure differentials between the different dryers make it hard to use a variety of wet side control pressures. So some systems have to use dry side pressure just because of the simplicity of the system. So you have to set in the right biases, the right differentials for the dryers so that you don't get.
Yes, Tim, I have here another issue that the new systems are using the dynamic set point on the wet side, which is actually dynamically calculated by the flow demand. If the flow is low, so we know that the characteristic of pressure drop is low, and that's how we can do this.
Right. So you have a dynamic offset. That's very good.
Yes. Yes, it's okay.
All right. Thank you both.